Hello everyone, my name is Phawx. In this video, we're going to be taking a look at eGPU performance differences between AMD 6800U, this is running on the GPU Max 2, versus Intel's Alder Lake, this is the 1260p. Both of these are the GPU Max 2. This is a prototype of the GPU Max 2 running Intel's Alder Lake 1260p. This doesn't actually exist anymore. This is the 6800U version. This is the production model. These are the only models that GPD is producing now. So a question that I got asked was, can Intel's Thunderbolt solution work just as well as on AMD? Now, AMD is doing it via USB4 via Thunderbolt 3, whereas Intel is doing it via Thunderbolt 4. So we have Windows 11 22H2 installed on both of these platforms, the same driver on both of them. I tested two different Thunderbolt cables. Both of these were rated at 40 gigabits. I got a Cable Matters one that was certified at 40 gigabits, if this can focus. So you see Thunderbolt 4 there. I tested both of these. Now I do get better bandwidth on the AMD platform, and I'll show you later on in this video, versus this, and that might be because this is a prototype. But overall, when we take a look at the benchmarks, it really doesn't seem like it matters all that much. For the most part, spoiler alert, the AMD platform works just fine, but if you want to see all the benchmarks and stuff, just carry on to this video. For other things that are kind of the same, I set both of the TDPs here. This is 35 watt and this is 35 watt. For instance, if we were to put one core on the 6800U, one core, a single core, goes to 4.7 gigahertz, but it requires 16 watts of power. However, if all 8 cores are active on the AMD 6800 platform, that only needs 32 watts. Going up in frequency will use a lot of power. However, when most of those cores start getting used, it will have a frequency cap. And more or less 32 watts is really going to be max. Same for this. However, we will see some benchmarks ahead where it does look like Intel's Alder Lake P cores, for whatever, better or worse, as we go down in resolution, things will change. Now, I did two different things here as well. On the eGPU platform, for 4K test, I did come out here as well and disabled the internal screen. So we have just eGPU going out to an external screen and not trying to muck up anything. And I did benchmarks as well of 1600p going from eGPU and then displaying on the display itself and seeing what types of results we get there. So there's interesting results for both of them, and I have benchmarks on Frametime graphs for you guys to check out. That's coming up right now. All right, let's start getting to the benchmarks themselves. This is a new tool that I plan on using going forward on my channel. The name of the tool is called CapFrameX. You can find it in the description field below. So a few things that we have to talk about here. All of these benchmarks here are 4K output, and I'm using HDMI out from the RTX 3090 itself inside of the eGPU directly to an external monitor. The internal display on the GPU Max 2 is disabled. Again, the main reason that we're doing these particular tests here is to determine if the eGPU solution on the AMD 6800U using USB4 via Thunderbolt 3 is just as good as Thunderbolt 4 on Intel's Alder Lake 1260p. So we're going to go over those benchmarks here. We're trying to create a GPU-bound solution as much as possible. Along the top, you're going to see, basically, I'm just trying to highlight to you. So if you see Borderlands 3 here, I am using the DirectX 12 API backend, and I'm using the Badass preset. Likewise for Cyberpunk 2077, I'm using the Ultra Ray Tracing preset, and for Doom Eternal, Ultra Nightmare and RTX is on. For every one of these tests, whether it's 4K output via the eGPU itself, or if I'm doing eGPU to the internal display at 1600p, all of these tests are not using image reconstruction at all. So no DLSS, no FSR, no XeSS, never ever. The only thing I have on is for the Tomb Raider benchmark, which has TAA, which is on. So let's get into it. First up, we have Borderlands 3. And this is one area where Borderlands 3 is just better on Intel's platform. So if we were just to take a look at averages alone, you can see that the 6800U is 6% better on averages. However, if we take a look at the 5 percentile, we can see that Intel is around 8% better on 5 percentile frames. And if we take a look at 1 percentile, AMD really falls behind here. And Intel is 55% better on 1 percentile FPS. And this really comes across pretty big. And we're going to take a look at Frametime graphs just after these bar graphs, so we'll get a better look at that. Next up, we have Cyberpunk 2077, and here we can see that AMD is about 2% better on averages. However, a 5 percentile AMD is about 4% better. But if we take a look at the 1 percentile, Intel is 30% better, well, 29% better than AMD here. And I'll explain more when we take a look at the Frametime graphs. I'll get there in a second. Next up is Doom Eternal. Now, this is one area where AMD is just doing better in 4K. Tables kind of turn on 1600p, and we'll kind of talk about that in a moment. But if we take a look at averages, AMD is around 17% better. And if we take a look at 5 percentile, it's 27% better. And 1 percentile, we're at 29% better on AMD's platform. So a clear win for Doom Eternal at 4K with ultra settings, which is kind of like way different versus Borderlands 3. So we're kind of, even though we're in a very GPU bound scenario here, what we're looking at is that there are some highlighted differences between Intel CPU, and that could be maybe optimizations done on Intel for Borderlands 3 versus AMD's CPU. If we take a look at a Frametime graph for Borderlands, this is Borderlands 3, even though you see all this up here. This is Borderlands 3. If we take a look, AMD in this particular instance is a orange-brown. And if we just kind of go along here, you can see how spiky AMD is along the entire time. And Intel is kind of nice and smooth. They'll have a few spikes along the same types of scenes. But here, Intel is fine, and then AMD is just going nuts for some reason. It's worth pointing out here that all of these tests, all of these captures are on the third run of the benchmark pass. So I do 3 runs, and on the third run, I capture. So this is really what that's kind of highlighting. And this is really weird right here, whatever's going on there. AMD just has these weird framey spikes that are noticeable. Like you can see this is like 100 milliseconds for our frame time. That's noticeable to the eye, versus Intel here is showing it to be just fine. If we load up the Frametime graph, again, this is 4K. This is a Cyberpunk 2077. This is, again, a third pass of the benchmark itself. And you can see right here, AMD has this weird frame spike here, which is noticeable. But for the most part, as we go through the scene, they're pretty much even. However, once we go over the fence in the benchmark scene on Cyberpunk, this is where AMD really kind of slouches behind Intel, and Intel just pulls ahead for this particular part. And it's where, if we were to go back to the bar chart here, if we take a look, this is that 30% better on Intel right here on the 1 percentile. So this is where Intel is pulling ahead, and it's visibly noticeable in this particular area that AMD is just dragging behind here. However, if we go ahead and load up Doom Eternal, we can see here that the brownish orange is now Intel, and the Frametime graph is consistently above. Now, I did run it a little bit longer because I don't have benchmark run. I'm just trying to do a scene that is identical between all passes. But you can see here that Intel is just consistently above the frame time on AMD here. So AMD is just a clear winner across the board for Doom Eternal. Alrighty, so our next set of benchmarks here, we have Grand Theft Auto 5, the max settings, Red Dead Redemption 2 at max settings. It is using Vulkan. I don't have it listed up here, but it is using the Vulkan backend. And Horizon Zero Dawn is using the Ultimate Quality preset. If we were to take a look at the benches for GTA 5, we can see that the average frame rate is around 4% better on the 6800U, which is negligible. If we take a look at the 5 percentile, though, we have a 20% increase on AMD, as well as the 1 percentile, we have a 20% increase. This is a marked improvement for the 6800U. So 6800U just overall better here. And this is kind of a contrast to Borderlands 3, where this is clearly better on AMD's platform. If we take a look at Horizon Zero Dawn, we have around a 7% better average FPS, which is noticeable. But if we take a look at the 5 percentile, we're at 7%, and 1 percentile, we're at 2%. For the most part, these are kind of identical, and this is where you're going to kind of see that the eGPU solution is more or less just fine for AMD. Then if we take a look at Red Dead Redemption 2, we're looking at a 15% increase on averages, 35% increase on 5 percentile, and a 30% increase on 1 percentile. So it's looking like Rockstar developed games are just better on AMD CPUs in like this metric here. When we do 4K ultra settings, we're just pulling ahead on AMD's platform by far. Now, this could be that this could just be a bandwidth thing, because between the both platforms, I was getting better bandwidth on AMD side. I was getting 20% better. We are showing 30% better here, but this could be just because a bandwidth preference, or it could just be that Rockstar is optimized on AMD CPUs. All right, let's go ahead and take a look at the frame time here. This is Grand Theft Auto 5. We can see that Intel is the orangish brown. And you can see here that AMD has these kind of weird spikes, but these are just loading into the scene, right? So Intel is doing better here, but this is kind of nothing to write home about. It kind of doesn't matter because this is the initial load, and then once the game is running, there is no stutter. So this is acceptable stutter, I guess you could say, is that it's not a big deal and no one really cares about it. But if we kind of just take a look here, AMD is better frame time pretty much overall. It's consistently winning throughout. So you look right there, the green line being AMD is frame time is always under Intel there, except as we get closer. So this particular segment right here, is like an airplane scene, like you're following a fighter jet, and it's just loading the terrain very fast. And then over here, it kind of switches to a busy city street, and this is where Intel and AMD kind of just both are fine. However, if we take a look right at the end, Intel spikes over here, and there's like an explosion that happens at the end, and Intel has a worse time there. If we compare the frame time graph for Horizon Zero Dawn, it is identical. There is nothing to write home about. This is kind of just like, I guess, Intel, no, this is 6800U. 6800U looks like it's slightly better. I guess this is why we're getting better averages, but yeah, it's identical. There's nothing to write home about here. And then if we load up Red Dead Redemption 2, and this is just, you can see that this loading spike here is just where I pressed to the start of the capture is off by a little bit, but you can clearly see like this is where it started. Now it could be that it's loading a bit faster on the AMD platform versus loading on Intel's platform, but it's also when I press the button to stop capture, because you can see right here, the benchmark ends here and the benchmark ends here for Intel. So don't think too much about that. It's really just when I press the capture button. Overall, though, when you look at it, AMD is just a clear winner in frame time over everything throughout the entire 4K scene. So 6800U is just pulling ahead here. All right, the last of my 4K benchmarks. This is Shadow of the Tomb Raider. I do have TAA on, but it is using the highest setting preset. Again, there is no other image reconstruction here. If we take a look, I mean, it's identical. 4% better, identical, and then even 1 percentile is 100%, 100%. Shadow of the Tomb Raider, it looks identical. If you take a look at the frame time graph here, this is the ending scene, so this is loading and whatnot, so you can ignore that end. But if you just take a look at this entire, it's exactly the same. Tomb Raider is a game that doesn't show any appreciable difference between the two platforms. They're exactly neck and neck. All right, so at this point, we're switching over to 1600p tests. So this is no longer doing an output from the 3090 itself to an external display. It's an output from the 3090 and then going back to the internal display of the GPU Max 2 running at 1600p. Still the same settings, but we have less resolution. So up first, we're going to take a look at Borderlands 3. You can see our average is 75.3 versus 68.7. It's a 18% increase on averages. 34% increase on 5 percentile and a 27% increase on 1 percentile. Once again, Borderlands 3 is just favoring Intel's platform regardless of resolution change. Likewise, for Cyberpunk 2077, we see largely the same result in that AMD does worse on the 1 percentile. That stutter that happens in that benchmark scene just happens again and is very pronounced. And then if we go look at Doom Eternal, this is interesting. Before we had the clear lead at 4K with the 6800U, now we're showing the 1260p pulling ahead. This could be differences on how I recorded the scene, but it also could be that at the lower resolution, despite having more bandwidth on AMD side, that the Intel CPU is pushing for higher frame rate. Again, as I said earlier on in this video, both of the CPUs on both these platforms, the TDP is at 35 watt, which allows them to really reach their max in terms of an all-core scenario. For example, the 6800U with one core at 4.7 gigahertz will require 16 watts versus all 8 cores at 3.5 gigahertz requires around 32 watts. So That is like the difference. You're saying, how could that be possible? Going up in frequency requires a ton more power, and the all-core frequency for the 6800U is 32 watts, versus what's happening on 1260p with those 4 performance cores. How the threads are managed, we might be able to see a benefit on the CPU side, which allows us to hit higher frame rate overall. So going down in resolution, running at 1600p on the display itself, we are seeing a benefit on Intel's platform here. If we take a look at the 5 percentile, it's 20% better. If we take a look at the 1 percentile, it's 20% better as well. So that is something worth noting to point out. Let's take a look at the Frametime graph. Here's Borderlands 3. And again, if we just take a look at Intel, which is the brown orange here, this is Borderlands 3. It's just winning across the board. The frame time is clearly under AMD's at the entire time. Borderlands 3 just has a much better time running on Intel. If we take a look at Cyberpunk 2077, again, you can see that. So AMD is running better. This is how it's getting those better averages. But if we take a look at this 1 percentile, AMD just falls far behind here on Intel. And this is a pronounced stutter that happens on this particular benchmark. Even though, again, averages are better, if you just look at the averages, you wouldn't really see this particular frame time graph here. This is a far more pronounced part on AMD's side in terms of feel. So it's just something to be mindful about. Then if we take a look at Doom Eternal, and again, this could just be because of how I was recording a scene and whatnot, because this wasn't a pre-run benchmark. This was me loading into a scene and trying to mimic what I was doing here. You can see that regardless, even when I'm going through it, Intel's frame time is consistently better than AMD here, running at 1600p. So regardless of anything, of whatever variations there can be, I ran this from a save file, from the same save file on each, and just kind of doing the same path, and you can still see Intel's pulling ahead here. All right, again, we're going to be taking a look at the same benchmarks, but again, we're taking a look at 1600p versus 4K. The one interesting thing here is that Intel has a 2% better average, but if we take a look at the 5 percentile, AMD is once again 15% better, and 1 percentile is around 18% better. Again, we have going down in resolution, even with the bandwidth change. We're still seeing, bandwidth is better on AMD's platform, but we're still seeing a marked increase. This could potentially just be eGPU bandwidth that is the difference here. It also could just be Rockstar games are more optimized for AMD CPUs. If we take a look at Horizon Zero Dawn, I mean, really, there's performance differences, not really much to talk about. So the one thing to note here is that Intel is doing a bit better here, and this could just be because of, getting that slightly better CPU speeds here. But we're mostly in the same avenue, so nothing really to write home about. If we take a look at Red Dead Redemption 2, the story is once again the same. AMD is 8% better on averages, 17% better on 5 percentile, and 21% better on the 1 percentile. So overall, still, the AMD is still winning. Again, this could just be bandwidth being better on 6800U versus Intel here, or again, it could be optimizations for AMD CPUs. Let's go ahead and take a look at frame times. All right, so here, again, where I'm pressing the capture button, you can see how this is kind of lining up. For the most part, it's still really kind of the same here. But the interesting thing here is that you can see AMD is winning here. And in this particular scene that you see right here, this is a flyby scene where you're loading in a bunch of terrain. AMD is doing better here, but when we take a look at the crowded city scene, what's interesting here is that Intel actually has a benefit, has better frame time during this busy city scene where there's gunfire and explosions, and we don't see that weird frame spike as well on Intel here. Here is the frame time graph for Horizon Zero Dawn, and I mean, they're identical. There's nothing to look at here. In terms of, is the eGPU as good as AMD for Intel? The answer is yes. All right, so now you're seeing how the frame times are kind of not really lining up here, but it's because where I stopped the benchmark, and this is my fault, but I mean, even if you were to offset these, right? Like if you were to push the Intel version to the left, you can still see that they match up scene for scene, and regardless, AMD is just doing better in each one of these. This is one area right here where Intel is doing better than AMD. I mean, it still doesn't matter. Like overall, AMD is just doing better. And the last set of benchmarks for 1600p, again, this is output directly onto the display itself. We are seeing a 17% increase on the 1260p, a 24% increase on the 5 percentile, and a 24% increase on the 1 percentile. So this is what's kind of interesting in that it kind of lines up with the same results that Doom Eternal's seen. So I almost have to imagine that this really just comes down to this better frame rate is really just Intel's P cores peaking ahead and really pulling ahead. If we take a look at the bar graph here, the Frametime graph, it really becomes apparent how much better overall Intel is here, just running at that slightly lower resolution. When we were doing super GPU bound and doing 4K, we saw no difference between Intel and AMD. But when we stepped down in resolution, this is where at one instance, same as Doom Eternal, where Intel is pulling ahead. So this is where we're most likely seeing a benefit just from those P cores on the Alder Lake platform and whatever thread director stuff is doing, and just really helping it pull ahead. All right, this last bit of information, this is the PCI Express connection bandwidth test in the 3D Mark suite. And using the 6800U, I did get slightly better throughput. I'm getting the theoretical max, so 2.61 gigabytes a second versus 2.24 gigabytes a second on the Intel platform. Now, it could just be that this was my prototype from GPD. For what it's worth, they don't make this anymore. So there's only a handful of these that actually exist of a GPD Win Max 2 that has Intel's Alder Lake. The only official one that they sell is the 6800U version. So again, the point of this entire benchmark suite was really to test eGPU comparison between Intel's Thunderbolt 4 versus USB4 via Thunderbolt 3 for AMD's 6800U. And overall, even when we take a look at the tests, even though we're getting the proper amount of bandwidth, we do see differences between the two platforms. One will win over the other, but overall, the main takeaway here is that they are both functionally fine, right? There's no real benefit outside of gaming scenarios or resolution scenarios that you would have to worry about. The eGPU solution is just as good as it is for Intel. So that is the main takeaway here. For anyone that was curious if they were worried that the eGPU on AMD side wouldn't muster up to Intel side, the answer is, if you take a look at Horizon Zero Dawn, they are identical between resolutions. So for the most part, they're fine. There is no real result there. You're only going to see benefits on CPU architecture side. So that's it. That's my video for today, taking a look at the differences on eGPU solutions between AMD's 6800U versus Intel's Alder Lake 1260p. As always, guys, thank you for your time, and thanks for watching.